Okay, class, today we're in lesson 2.3. Lesson 2.3, scientific notation with negative powers of 10. Scientific notation with negative powers of 10.
Okay, we've gone from scientific to standard notation. Now let's just do the reverse. Let's take a look at an example where we're given the standard and we're being asked to write it in scientific notation. Now, when I look at this number, I see it's very, very, very small. Now, what does that tell me? My exponent is going to be negative. Okay? We're to write 1, 2, 3, 4, 5. I'm going to count those zeros. In scientific notation. Recall that in scientific notation, it's the product of a number between 1 and 10. So I'm going to have to move this decimal point such that this first factor is between 1 and 10, and then the second one is a power of 10. Well, how many places do I have to move the decimal point? 1, 2, 3, 4, 5, 6. So it becomes 5 and 25 hundredths times a power of 10. And how many place 1, 2, 3, 4, 5, 6? It's a negative 6. A negative 6. And now I have changed. I've gone from standard to scientific.
Okay, make sure you get the key objective in your notes along with the actual definition of scientific notation. Key objective and the definition of scientific notation. Make sure that's in your notes. Writing a number in scientific notation. To write a number less than 1 in scientific notation, move the decimal point right and use a negative exponent. For example, this number here, 0.0783, is less than 1. So you move your decimal place to the right, all right, and then you write your exponent as being negative. So here we go 1, 2, and remember we got to stop where the number is going to be greater than 1 but less than 10, and that'll be the case right there at 7.83. All right, but now how many spaces did we go? We went 1, 2, so that's going to be to the negative 2. Okay, when writing a number in standard notation, to translate between scientific notation and standard notation with very small numbers, you can move the decimal point the number of places indicated by the exponent on the power of 10. When the exponent is negative, move the decimal point to the left.
Many times when we see real big numbers, we kind of wonder, is there another way, a shorter way of writing that number? And I'm sure you've been introduced to scientific notation. That is a shorter way of writing really large numbers. Let's take this example. In this example, we've been given that big number in scientific notation. And we're being asked to write it in standard notation. Standard would be that big number that we would see. This is scientific. So we're being asked to write 5 and 24 hundredths times 10 to the 7th, which is in scientific, in standard notation. Remember the rule that says when you have a positive exponent, the decimal point moves to the right, because we're going to end up with a very big number. Okay? So if we have 5.24 hundredths times 10 to the 7th, and we want to write it in standard notation, and it's to the 7th power, we're going to take our decimal going to move it 7 places to the right. Well, let's see. Here's 1, 2, we need to add a 0, 3, 4, 5, 6, 7. So that number, which is written in scientific notation in standard, is equal to 5, 2, 4, 1, 2, 3, 4, 5 zeros. And when we point off, we find that in standard notation, it's 52,400,000. Okay, let's try another one. Once again, we're being given the number in scientific notation, and we're asked to write it in standard notation. Well, the first thing I see negative. I see negative exponent. If it's negative, it's going to be real small. If it's positive, it's going to be real big. Big number. Okay? All righty. Recall that the exponent tells us, if it's negative, tells us which direction. Are we going to go to the left? And we're going to move the decimal point how many places to the left? 5 places to the left. So we're going to write 3 and 25 hundredths, and we're going to move the decimal point 5 places to the left. Well, I'm going to start here. I left room to add some zeros. This is 1 place. I need to add a 0, that's 2. And add another 0, that's 3. Add another 0, that's 4. And 1 more 0, it's 5. So 3 and 25 hundredths times 10 to the negative 5th, which is in scientific, in standard, is equal to 1, 2, 3, 4. And there you go. Piece of cake.
Okay, if you missed it the first time, get the key objective and also the definition for scientific notation in your notes. You should have seen the same thing for example 1. This is for example 2, but the objectives is the same. Okay, example 1. The average size of an atom is about 0.000000003 centimeters across. Write the average size of an atom in scientific notation. Okay, all you're going to do is move this move this decimal place until it gets to right at that 3. Why the 3? Because at this point it's greater than 1 but less than 10. Now how many spaces does that take? 1, 2, 3, 4, 5, 6, 7, 8. And since we're moving the numbers that's less than 0, we know that the exponent has to be negative. So our final answer then is 3.0 times 10 to the negative 8. Example 2. Platelets are one component of human blood. A typical platelet has a diameter of approximately 2.33 times 10 to the negative 6 meter. Write 2.33 times 10 to the negative 6 in standard notation. All right, as soon as we see times 10 to the negative 6, we realize that it's going to be a number less than 1. So all we do is count negative 6 spaces, or count 6 spaces in the negative direction. So if we start off here, then we simply count 1, 2, 3, 4, 5, 6. So when we write the number 2.33 times 10 to the negative 6 in standard notation, we end up with 0.000000233.